Hello, so in here we are going to look at phase transition and Gibbs free energy. Melting point, we learned that it's the temperature at which a solid starts to turn into liquid. A better definition of that is to say that it refers to the temperature at which the solid and liquid state of a system, or in this case, of a substance, I should say, are in equilibrium with each other. So that means that they can coexist. So for example, at 0 degrees Celsius under 1 atmosphere, that's the melting point temperature of water. So if you have 100 grams of liquid water, 100 grams of ice, and you come back 1,000 years later, and if the temperature is at 0 degrees Celsius, you still have 100 grams of water, 100 grams of ice. Neither one has been converted into the other because the rate of fusion is equal to the rate of crystallization. And so that's what we mean by equilibrium. So if they're at equilibrium, delta G for fusion would be 0. So remember a system that is at equilibrium, then it neither increases nor decreases the entropy, overall entropy of the universe, so delta S universe will be 0, and delta G is minus T delta S universe, so therefore this will be 0. And so that, because of that, delta G fusion minus melting point temperature times delta S fusion equals to 0. And so that means that the melting point temperature is the ratio of delta H fusion over delta S fusion, or delta H fusion is equal to T melting point times delta S fusion. And you can do the same thing for boiling point temperature, because boiling point temperature, a better definition of it, is to say that it's a temperature at which the gaseous and the liquid state of a substance are in equilibrium with each other, which means they coexist. So if you have 100 grams of steam, 200 grams of liquid water, and you're at 100 degrees Celsius, you come back 2,000 years later, you still have 100 grams of steam, 200 grams of water. Neither one has been converted into the other. And that's what we mean by equilibrium. So the rate of evaporation is equal to the rate of condensation. So for that, delta G vaporization is 0. And so then the delta H vaporization minus boiling point temperature times delta S vaporization is equal to 0. So then the boiling point temperature is equal to delta H vaporization over delta S vaporization. Or delta H vaporization is equal to boiling point temperature times delta S vaporization. So now that we know about this, let's put it to work by solving two examples. So let's go over these examples here. So let's first go over this one. It says the heat of fusion of ice is 6.01 kilojoule per mole. Calculate the entropy of fusion of ice. So entropy of fusion is basically by how much disorder increases for the system as you go from solid into liquid. Now, of course, it will be positive delta S, but by how much? So we know that delta G fusion is 0. That's equal to delta H fusion minus melting point temperature times delta S fusion. So as a result, delta S fusion is equal to delta H fusion over the melting point temperature. And so this is in kilojoules. I convert it into joules because we often express delta S in terms of joules. So this comes out to be 22 joules per Kelvin mole. And of course, make sure you convert the temperature into Kelvin. Melting point temperature of water is 0 degrees Celsius, which is 273 Kelvin. So that means that for every mole of ice that gets converted to liquid water at 0 degrees Celsius, the entropy of the system increases by 22 joules. So next we are going to do another problem. This one, the molar enthalpy of vaporization and the molar entropy of vaporization. So delta H vaporization, delta S vaporization for substance G are given. So this is a hypothetical substance. So these are the values. And it says calculate the boiling point temperature of G. Well, to calculate the boiling point temperature, we learned that that's equal to delta H vaporization over delta S vaporization. If you ever forget that, just look at the units. Joules per mole, Kelvin. So joules per mole, joules per mole cancel each other out. 1 over Kelvin is the same as Kelvin. So when you do that, the temperature comes out as 128 Kelvin, which is minus 145 degrees Celsius.